Hello and welcome to the video. For those of you that haven't seen, this is the ZOHD Altus. It's only been out a week or two. Now I did a video a little while ago just showing how it came in the box, but in the subsequent few days I have built mine out. So we have a walk snail system in the nose, we have room for a very large battery, GPS, and then we have a flight controller and all of the goodies at the back. So INAV 7.1 and all that goodness, running on a SpeedyBee Mini. Now, I am excited about getting this up in the air to fly, and you'll see why in a minute. You need an awful lot of weight in the nose in order to get the center of gravity right. I think it's really designed more around having an action camera and a battery in the nose, because if you just run it with something like a walk snail unit like I have here, then you are going to have quite a lot of battery in here. I'm probably going to run mine now after building this out on a 4S2P lithium ion pack, 7,000 milliamp hours, which I'm hoping will mean that this can stay aloft for a very long time. Particularly, I'm hoping with its kind of more flighty, floaty characteristics. So I thought it would be useful to those of you that have been asking how I'm building mine out, for you to show not only the flight controller and how that's put together physically, from a connection point of view, but also in INAV, and then kind of show you how it's all fitted inside. So time codes down below if there's something specific you want to see, but let me show you how I've put mine together. So this is what the central nervous system of this model looks like before we actually install everything. I've made all the ends off, connected it all and configured it in INAV, but we'll jump on the computer. I'll show you the configuration in a moment, but I thought it'd be interesting for you to see how everything has plugged together. Pretty straightforward and easy. The manual that comes with this little SpeedyBee F405 Mini kind of shows you where everything is plugged in, but I'm a big believer in if you actually see it with your own eyes, it makes everything a little bit simpler. So very quick tour, and then we'll go through each piece individually with a little bit closer up. I have a receiver. This is actually an old FreeSky receiver connected via S-Bus. I've also got smart port telemetry connected so that I can get the telemetry back for the radio for things like the INAV Lua script. We could also have gone with a CRSF connected receiver, something like Express LRS or Crossfire. Over here we have a Maytech GPS. These kind of GPSs are incredibly easy to connect. We'll cover why that is in a moment. Over here then we have the connection, which is the USB-C cable, and also the buzzer that has a supplied cable marked BAR that just goes into the flight controller on the side. At the back here, this is the cable that's going to have the ends made off for both a power connection and a transmit and receive pin. That's going to power the nose that has the walk snail system in. I've designed one for that. Not happy to share the files publicly for that yet because it's a little bit rough and ready, but it'll do for the maiden flight. And then we have the power, which is a little bit complicated only because we have one input, but we have two outputs because there are two XT60s inside the model. So let's start with the power while we're here. So the way this works is that the outside power pads are for the battery, the plus and minus, and that is where I have soldered on this flying lead. So that's going to go into the model with this at the back. The battery bay is going to be here, so this is going to come forward into the battery bay. These two cables were actually supplied as part of the build. So this was a Y cable that connected the two XT60s coming in from each wing into one connector for the battery. What I did is I just cut the end off that and I've soldered them onto here. Now the really nice thing, I hadn't really appreciated this when I was thinking of building it, is that the pads are both at the top, but I'm not sure if you can see it, but they're also at the bottom. It gives you a huge number of places to solder the cables onto. So for something like this, this cable is soldered onto the top of the flight controller. This one is soldered onto the bottom. I've also attached the cap, not strictly necessary for something like a wing, but I've put it on there just to make sure the signals are all nice and smooth. But that now means that I should just be able to plug this into the model, and once it's seated, and I'm going to use my double-sided foam tape trick, that's the one that's on the bottom here. That's how I'm going to connect it. Then these are going to go into each of the wings, and then the other cable is going to go to the front. That's where the battery is going to plug in. So that's the power stuff taken care of. Let's do the receiver next. So this is an old FreeSky receiver plugged into the S-Bus connection. That's the first one here, working beautifully. And you can, by turning on soft serial, we'll see it in a moment, get smart port out of TX2, which is this third pin along. So I've just connected that up. That means I'm getting smart port. Now, obviously, if you're going to be using something like Express LRS or Crossfire, something that talks CRSF, then you're going to plug it into the T1R1 V&G here on the flight controller. That's going to be where you're going to plug it in and change that setting. Again, I'll show you that in INAV shortly. Next piece then is this little cable. Not a lot to really talk about here. This is where it plugs into. This is where we're going to plug it into the computer in a moment. And then finally, underneath, we have a couple of extra connections. The very bottom one here that's actually marked on the bottom, so you can see here it's got ground 5 volts, transmit, receive, ground and S-bus. This is designed to go into some kind of HD FPV system. I'm actually going to remove the extra ground and S-bus cable. That's more for your DJI stuff, and I'll just have the 4 cables going forward. I'll just unplug that so you can actually see below it. This is where the GPS plugs in. This little port here. It isn't actually labeled, which makes it a little bit more complicated, but this is where it plugs into. Now, the really nice thing, this cable actually comes without the ends made off, and it has this little connector included for the GPS. So all you need to do is look at the GPS, match the 5 volt ground and all the other legends that are on the side of the GPS, and plug the cable into the supply connector, and then push that connector in. Zero soldering. I absolutely love that. So with those things all connected, it now means that we're almost ready to put it into the model. But before I do that, let me very quickly plug it into INAV and show you how I've configured INAV 7.1 for this so far. So let's plug it into the computer with the USB cable. I'll very quickly show you how it's all set up. The nice thing about this is it's also powering the receiver and the GPS with this as well. And I really like that about the SpeedyBee stuff. It means that we don't have to have battery power for everything to work. See here, the GPS is there. If we go down and have a look at the GPS stuff, we can see that if we scroll down, we're getting lots and lots of messages. There's one timeout, but the messages are coming through with 0 errors. The GPS is nice and blue. That means we're in really good shape. And as we move the bits and pieces on the desk, it's flying the right way round and the plane is the right way up. It's telling me navigation isn't safe because it hasn't yet got a GPS lock, but everything else is green. And when the GPS locks, that'll go green, which means we can get it and arm it. So let's go through and talk about what we did. Standard stuff. Everything I've done in here is exactly how I would set it up in the INAV for Beginners series. I'll put a link below to the last one that I did. I haven't done anything different, even though it's 7.1. INAV has done an amazing job of keeping the setup consistent over the last 5 or 6 setups. Mixer is set for an airplane V-tail, so I uploaded that. I haven't selected it with differential thrust. There's only one motor output. I'm going to have to calibrate the ESCs. So we have 2 aileron connections. I'm only going to connect to one of those at the moment because I have a Y cable. I could split them and maybe set up some kind of flap control. Then we have the stabilized pitch and yaw, the elevator and the rudder being put together for the next 2 servos, and that's for the V-tail. Outputs are not yet turned on. That's one of the last things I'm going to do when I put it in the plane and check for throws. And the only thing I did just double check what the center positions were with all of my servos like I normally do. I'm almost certainly going to have to reverse one of the V-tails when I pop it in and test it. Ports configuration, let's go through this. So if you're using Express LRS, then you want UART1 to be set for serial receiver. If you're using something like Crossfire, those 4 pins that I talked about, this is the one you want to set up as serial RX. I'm using UART2 set for serial RX. That enables that S-bus connection that I'm currently using. UART3 is set for the GPS. That is the hardware setup that's done by default. Again, super easy to do with that supplied cable that you get with this. UART4 is not used for anything. It is available on the side via pins, but unless you're doing something with airspeed sensors, you're probably going to need it. UART5 is set for the MSP display port. That is how I'm going to run my Walksnail avatar system in the nose, but that's also how you run your HD0 and other pieces too. UART 6 is set for MSP. That's actually for telemetry. We need to leave that alone. And finally, because I've enabled soft serial ports, that's given me soft serial 1. That has allowed me to set it up as smart port. That's giving me that telemetry back on that old style receiver. Again, you wouldn't need to do that if you were using UART 1 and those 4 pins for a CRSF connection for something like Express or LRS or Crossfire. Configuration looks pretty standard too, not changed anything in here. Although the magnetometer is connected, I've kept it turned off because there are a number of magnets close to the GPS compass mount in the model, sadly. And the only things I have turned on in here, enabled the USB CPU based serial ports. That's so that I have that option in the ports tab to configure smart port. I have turned on set GPS for navigation and telemetry so that that appeared at the top, and the only other things I've done is made sure that permanently enable launch mode, which is how I do it, is turned on, and continuously trim servos on fixed wing is turned on as well. That's all I've changed in there. Failsafe I then set to return to home because the GPS is configured. PID tuning I haven't covered, we'll see what it flies like. Advanced tuning, I've made a couple of setup changes in here, more around things like my auto launch settings, the default throttle and stuff like that. We'll see how that all works when we get there, but I've got my idle throttle relatively low. I think this is going to be reasonably floaty, so I'm not going to have to hoof it. So just under half throttle, and then the climb, it's going to climb at 1800, so not maximum throttle to pull out as well, but everything else is pretty much the same. Receiver, now in here, if you're going to be running CRSF, you would set it for CRSF in here. However, I'm running S-Bus, so that's how I've got all this set up. This is a bit old school. I appreciate that for the video. However, for my build and the battery and everything I want to use with it here, this all works for me. Modes is going to be my standard mode setup. I've imported this from other models. This is the standard one that I have on the Taranis radio I'll be using with this particular model for the flight. And you can see here that I've got Horizon, Manual and Acro set as the main flight modes, and Nav Return to Home is on my Oh Dear switch. Also got Auto Tune and Auto Level Trim. Auto Tune is going to allow me to tune the thing. Obviously, I'll do that in acro mode. Auto level trim is going to adjust the offset angle so it maintains its height at cruise speed. And I've got the beeper turned on as well. Helps find it if it comes down in a bush. And that's about it really. The only other thing, I did play a little bit in the on-screen display. Make sure that the system is set for the avatar stuff, which is what I'm using here, and then moved everything around to be how I want it. I've added a couple of extra things because this is hopefully going to be a reasonably long flyer. The rosette at the top for my direction, and also my variometer here on the right hand side, just so I can see when I'm catching thermals. I think it's going to be relatively floaty like the swordfish, so I've added that in as well. So with all those settings done, the only thing I really need to do is go into the outputs and turn on the outputs. Now again, the ESC protocol, unfortunately, with the ESC supplied on this first version, they are not D-Shot capable. It would have been lovely to select D-Shot, but I'm going to keep it as standard. So that's going to mean I am going to have to do some kind of calibration with the motors. That's no big deal. I've shown that in lots of other videos. And I have increased the servo refresh rate to 100 Hertz. These are digital servos, so they will work with that fine. So let's just save and reboot. And now it's ready to plug into the model itself. So let me show you how everything has fit inside. Let's start in the nose. In the nose here I have the walk snell unit that is behind a custom printed 3D front. I've designed that. As I said, I'm not really going to share that yet. It's a little bit rough, but it's going to work for the maiden flight. And there is the camera and also the version 1, the walk snell unit, up there in the nose. Now that means that I don't have any kind of weight up here like an action camera would give me, so all the weight's going to have to come from the battery to get the central gravity. Now the plane itself with everything in it is about 644 grams, and I'm going to need this battery which is 411 grams in the nose in order to get the central gravity about right. Now there is easily enough room to fit that size of battery in here. So we're gonna not struggle to kind of get that capability and that kind of big battery in here. But without that big battery, I cannot get the center of gravity anywhere near. So if you have an action camera in the nose, then you can take off that weight from whatever battery that you need. But playing here, looks like batteries anything from about 350 up to this, which is about 411 grams, is what you're going to need in order to get your center of gravity. So if you're trying to use something like a little 4S 2200, it's going to be tricky unless you are going to be putting in something like an action camera in the nose or something like a GoPro. Use my same standard way of putting all this together. Here at the side we have both a servo connector and a separate power lead that I plug in to power the HD system once the GPS has a lock. Talking of the GPS, it's under here. I mounted as you would expect. I did cut out a slight recess and that's helped me get everything in place. And then it's a case of, well, what about all the flight controller stuff? I'm going to take this wing off so I can get it more easily under the camera, because actually it's all fitted in really rather well. And if I just undo this thumb screw here, I can pull the wing off, take out the carbon rod, and then that means that we can zoom in a little bit and I can show you inside here. So where the flight control and other pieces are, as you can see here, has fitted in quite easily, tons and tons of room. So let me point out a couple of these things for you. So the flight controller is at the bottom of this stack. Then on top of it is the receiver with the antennas coming out either side. This is the board to connect to it, which goes at the side here. So that's going to be my buzzer and also my connection. And then everything else, as you can see, has kind of fitted nicely around it. There is lots of additional room here. I haven't had to really fight with anything. Just put all the cables together with a cable tie just to keep it all nice and neat. But this has gone together really, really nicely, and I don't particularly worry about running out of space. And also, because of the way it's put together, I can still get to the thumb screws to put the wings on and off. So there we have it. That is how I have built mine out. Everything has gone together relatively easy. It's probably taken me 4 or 5 hours, and a lot of that was designing the kind of grille at the front. Again, it would have been nice, I think, if there was a more easy out-the-box way to mount a HD system in the nose, and once I've refined this, I might share it on Thingiverse as I normally do. But with that 7,000 mAh pack in the nose, and what I'm hoping for is a relatively efficient flight, I'm hoping that this is going to be one of those planes that you can throw up and just relax and enjoy the scenery and give you a sensation rather than like that wonderful dream of flying that we sometimes get if you're very lucky. The flight controller has gone in very easily as well. There's definitely room at the back for a bigger one if you wanted to. However, keeping it relatively compact with that SpeedyBee F405 mini wing means that there's tons of room for all the connections. If I want to swap and mess things around, I can get in there too. So all I need now is a little bit of sunshine and hopefully one of my flying buddies to come and spot me as well. So keep your fingers crossed that the weather improves here in the UK, and I will post a full flight review video with all the standard settings and everything that I normally do as soon as I've got that done. But I'm excited to see what this flies like. These kind of planes are right up my street. Thank you for watching my video. Check out the playlist, and adding Painless 360 to your search terms will help you find my content. If you haven't done so already, please hit the like and subscribe button. It helps a lot. You can support the time I spend here answering questions and helping others by using the links in the video description.